Hello again, and this is my longer version of my demo for my project. So I can go into more of the design aspects of what I did. So, so, so basically for my computer vision values, I made it so it takes in the beginning of the program, it takes a value of a photo of a photo with no figure in front of it, and it takes the value of that, and it takes a picture of a figure with a figure in front of it, and it takes the difference between those two values in those two different photos, and that's what it analyzes whenever it takes a new picture. Then it uses those two values from the two base photos to then determine if a figure is there or not based off the values from each subsequent photo image. And it does this through using Raspberry still and taking a 460 by 640 by 480 image every 2 seconds. And it uses the Raspberry still command given in the Raspberry Linux command shell. So that's basically how that works. And as you can see in the final version of this project, like if I had more time, I would probably find a way to situate this on top of the robot to make it more mobile. But for now, this is more of a proof of concept that, but as you can see, it would still work if the camera was just right in front of the robot while it's traversing the maze. And it would still be able to recognize what it is. But I wanted to show it on the HDMI monitor instead so you can see that it has a live feed of all of the changes of the images, like as a live feed of the images coming in. So, and then the second important part of the project was the mouse. So the mouse had a lot of problems, but I got all of the mouse to work except for the incomplete parts of the motor, and so that I basically solved that by, well, I basically constructed it using so I had 3 IR sensor pairs, and these are for left, right, and middle. And these give out accurate readings by going off 80 mux. So I have a state machine just for getting infrared values from these 3 IR pairs. And then it has a state for left, middle, and right, and it changes which one it reads from by changing which port A, which are these that it powers, and it changes which 80 mux, which ADC value port it reads from, changing the 80 mux part of the register in the microcontroller. And as you can see, it's using the Omega microcontroller, and for the motors, it's using an SN7 44, I don't remember the rest of the numbers, motor driver, and it's using 2 DC motors attached right here. And the thing I got working is that the DC motors had a lot of problems, like a lot of issues, and I think most of it came from hardware, because when I did get the motors to work, it worked fine based off the software I provided, and I wasn't like tripping or anything. So that it reassured me that my PWM like init code was right. And for the PWM, I used phase correct PWM, and I made it so it goes off a value of 255. And so the lower the value, the higher PWM it is, because I made it when it ticks going up and resets going down using the PWM tick. And so I had another task just for the PWM motors, and so basically what it does is that for this version, and this makes it so it changes the speed of the motors, based off the 2 IR sensor readings, because it uses the PID control algorithm. It uses P, I, and D, because P is for proportional, I is for integral, so it takes all of the errors from the last like last 1,000 or so readings, and then these for the difference between errors from the last reading to the current reading. So it uses all three of those parts for the control algorithm, and then so that's basically it for the completed version of the project. If I could do it again, I would probably order more replacement parts because one of the reasons the motors were acting finicky throughout the entirety of the project was due to the soldering on the encoders. And I also think maybe I fried the motor driver, like internal connections, when I first assembled it. Okay, so that's, and I hope you enjoyed looking at my final project for 122A.